Okay, hi guys. It is 6 o'clock. Shout out to Carwan for being here, and anyone else who comes, you're welcome to join in the chat box. Today we're doing just a quick review, and I went through the challenging test, and from the challenging test, I picked out the overall themes. So I'm not going to really show you questions as much as I'm going to show you how to deal with the overall themes of each question that's going to be on your challenging test. Now, as a reminder, the challenging test for me is tomorrow, Wednesday, September 26th. The challenging test includes higher depth of knowledge questions, essentially lots and lots of wordy problems. Your next test, the test that's not as challenging, where the questions are much shorter, but the test is longer, that's going to be on Thursday, September 27th, and that is a test that all of the geometry teachers at our school will give to everyone else. I'm not sure if I'm going to do a review for that because this should be pretty much set, but we'll see how it goes. So, YouTube review. Yay, the crowd goes wild. The first thing, interestingly enough, none of my things came up. I guess we're going to go here. Segment addition, 3 parts. So we've already talked about segment addition before. However, all of the problems I've shown you in class have dealt with 2 parts, and that is what is a little bit different. So for example, I have a line, and if I told you that this whole line from here to here equaled, let's make this a little bit smaller, let's say 20. And let's label this A, this D, and then we'll put little pieces inside here. Here's my B, and here's my C. Well, if I told you that this section was 5, this section was 6, and you need to find X. Well, this you probably already know what you would do, because really it's like you have $20. You spent $5 at one store. You spent $6 at the other store. So how much money do you have left? Now, the official way to write this problem would be 5 plus X plus 6 equals 20. We combine our like terms, and we get X plus 11 equals 20. Subtract the 11 from both sides, and we get X equals 9. You probably were able to figure that one out in your head. It's here. Now, unfortunately, the question on your test is going to be a little bit harder than that. It's actually going to make us do geometry with it. And so the geometry piece, of course, comes from our line. And so, but instead, maybe we would have like 3x minus 6 is this segment. X plus 3 is this segment, and then this segment might be 2x plus 9. And we still have to figure out what each of these values are. Now, for our case, I'm going to make it more challenging, and I'm going to say we need to find all parts. So after we find our X, we're also going to have to find out AB, BC, and CD. So perhaps they would have told you that this entire measurement, all of AD, is, let's say, 39. And we have to figure out what it is from there. So let's see, will this work? Yep, it'll work. So basically, same thing. All we're doing is adding out the parts. It's like I spent this much money at AB. I spent this much money at BC. I spent this much money at CD. So I'm going to add all of them up. So we've got 3x minus 6 plus x plus 3 plus 2x plus 9. Now, don't be a silly fool and be like, oh my gosh, there's a negative, things have to be subtracted. Not the case. All we do is we add all of the pieces together. Now, some of you will be able to just look and be like, oh, 3x plus x plus 2x, that's 6x. Some of you will be able to do that without writing the step out. I don't care how you do it because I'm not going to see your work. Why? Because it's on the computer. Ta-da! Okay, let's combine like terms. We do have our 3x, our x, and our 2x. 3 apples plus 1 apple plus 2 apples is 6 apples, or 6x. Then we have our next part here. We have negative 6 plus 3 plus 9. So negative 6 plus 3 is going to give me negative 3. Plus 9 is going to give me positive 6. Again, you could have just done that on the calculator. And that equals 39. Oh, it's not going to work. It doesn't matter. We'll get a decimal. Next, what we're going to do is subtract 6 from both sides. We subtract 6 from both sides because we're going to try to do what's called isolate the variable. This is going to give us 6x equals 33. And then divide both sides by 6. And you get x equals 5.5. Oh my gosh, we got a decimal. It must be wrong. Nope. You're going to get decimals from me. It's no big deal. Now, this would have been done if it asked us to solve only for x, but we want to solve for all of the parts. So now we have to go back to what we did in algebra, which is substitution. So I'm going to take this 5.5, and now I'm going to have 3 times 5.5 minus 6. On my calculator, 16.5 minus 6. And that's going to give me 10.5 for this first section. I'm doing this in my head. I'm sorry if I get the math wrong, but I think that's correct. Okay, here we've got x plus 3, so that pretty much is 5.5 plus 3, which will give us 8.5. So in theory, that would be 19, so this should give us 20. 2 times 5.5, when we do our substitution, plus 9. Well, that's 11 plus 9, which gives us 20. So when we add all those numbers up, 10.5, this is our check. You don't have to do it, but if you just want to check, we add all these pieces up, we get our 39. Holy moly, we did it correct. So segment addition, it's literally what you learned in 2nd grade. 3 crayons plus 4 crayons plus 2 crayons. What makes it harder is it deals with variables. That's the algebra piece. And what makes it even more challenging from that is in geometry, you have a segment. Now, you would also need to do the same thing if you happen to have an angle. So just because of that, an angle, you might have to add all of those up also. Another question in your test deals with determining parallel lines. Now, a couple things. Here is a set of parallel lines. I know they're parallel, even though they don't look parallel, because I'm going to write L is parallel to M. This right here will be my transversal. Now, the hard part of your test, these things are often labeled, but there's some of them where they're not. This is when it gets catchy. The only times that you could determine parallel lines is if you have corresponding angles. Corresponding angles would be something like angle 2 and angle 6. That does not look like a 2. Whoops. Angle 2 is congruent to angle 6. If we know that that's the truth, we can say these lines are parallel. Another way that you could do it is you could do it by alternate interior. So for example, they could say angle 6 is congruent to angle 4. So if I come back over here, here's my 6, here's my 4. If they tell us those are congruent, we now know those lines are parallel. They also could do it by alternate exterior. 2 and 8 are alternate exterior. So if all they told you is they drew you a picture and they said these lines match up or these angles are such and such are congruent, then you know because of alternate exterior angles, they're congruent. Now, if the alternate exterior angles are not congruent, then they can't be parallel lines. That means that maybe the lines look like that instead, and they would end up touching. Another one, the same would be true for same side. If they equal 180. So for example, you have angle 4, let's change color, and angle 5. Now, here is the most important. It's never for vertical angles. Whenever you have vertical angles, you might have parallel lines, but you are not guaranteed parallel lines. Vertical angles have nothing to do with parallel lines, nothing at all. So this is an image I drew earlier today with a student who stayed after school. If I have this angle here, If they tell me this angle here and this angle here are congruent, well, I know that those angles are corresponding. And I know that this angle touches this line, and this line. That's what it makes it up. Because I have these two stars here, that means that these two lines are parallel. Because this angle touches those three lines, the two lines that are on the same side make parallel. Let's look at another example. If they give you this angle here and this angle here, well, what sides? This angle touches this side right here. It touches this line right here. And this one touches this line right here. So because of that, I know those two lines have to be parallel. Here's a non-example, very important non-example. If all they give you is this vertical angle and this vertical angle, if we make our marks, we know that this angle touches this line here, and we know it touches this line here, and then this angle touches the same. Because I don't have another one here or here, I can't create parallel lines. All I have is two lines that intersect. I don't have parallel lines. Vertical angles do not give you parallel lines. The only things they can are corresponding, alternate interior, alternate exterior, and I'm going blank on the other one. Same side. That's it. That is absolutely it. Next, congruent triangles labeling. I think this might come up twice. This is very important. If they tell you triangle XYZ is congruent triangle WTU, good thing I didn't write WTF, I have to draw this X, Y, Z. Here's my other triangle, WTU. The order matters. If this X is here, that means it has to match to this one right here. It has to be translation. When we label triangles, we have to do it by translation. Here's my W here. Here's my T. They have to match up. If I have my Z here, my Z here, and my U here, they have to match up. It has to go in order. If it does not go in order, you are most likely not going to get the problems correct. What is missing? This is one of the fun ones. Here I've got, let's say, two triangles. Now, the main thing to pay attention is what are they asking you about? If they give you these sides and they give you these angles, this is where the conundrum is. Because if they tell you that picture and they want side, angle, side, that's going to be totally different than if you get the exact same picture and they say that they want angle, side, angle. So the order matters. So right here, I have this is an angle and this is a side. So I've got my angle, side. Now, some people are getting confused because everything's blending together. So I just say go like this. Dude, pick a triangle. Here's my pretty triangle. This is the triangle I care about. That way you're not really paying attention to all that. Here's my same triangle with my same things that are the same. Now, what's funny is this. If I have side, angle, side, I know I need another side. I could do this side, but that would give me a bad word. So we don't want to do that, right, Nick? No. We need to make sure that we make our sandwich. So we would need to know this bottom side matches to this top side. And that's going to give me sass. Here, we have an angle and we have the side. If we got the bottom side, that would give us side, angle, side, which is not what they want. They want angle, side, angle. Okay? So that means that we need to have, we need to have this angle here matching with this angle for vertical angles. So when it comes to what's missing, you could have the exact same picture, but the only thing that might be different is if it's side, angle, side, angle, or angle, angle, side. So really pay attention to what they're specifically asking you for. X triangle, straight line. This is really for the test more on Thursday than today or than Wednesday. Sometimes they'll give you pictures and you have to find the missing angle. Like maybe they might tell you this is 40. They might tell you that this is 110. Then you need to find this angle here, and maybe this angle here. Okay. So basically, you always look for, okay, do I see an X? Well, I see an X. An X helps me here and here. That gives me vertical angles. Well, I also see that this measure here has to be 110 because of vertical angles. Do I see a triangle? I see some triangles, but I don't have enough data to do anything with it. So let's see the straight line. Remember, straight lines are 180, triangles are 180, and X's give us congruence. So because I see a triangle, I know, or a straight line, I know that this line is 180. So this is 110. I'm going to do my 180, subtract 110, and that tells me that this angle right here is 70. Now I look again. Do I have an X? Yes, because of an X, I know that this is also 70. Okay. Other things I can do, if I know that that is 70, I could extend this, and I have parallel lines. I have here 40 and 70 is 110. So that means that this one right here has to be also 70 degrees. I can see I have alternate interior angles. You can see that there's a Z. So that means this has to be 70. And here, highlight tool, this 40 here and this angle right here are also alternate interior angles. So this is 40. So the main thing to look for is, can I see an X? Can I see a triangle? Can I see a straight line? Now you also can look for a Z. Z's give you alternate interior angles. You can definitely look for that. The X, triangle, straight line is pretty much we're always going to get you to where you need to go. Midpoint bisector. Couple things. You will have a question tomorrow that says what's that something is the midpoint. Anytime you think midpoint, just think of the word middle. Midpoint and bisector are relatively synonymous. The bisector actually intersects the segment at its midpoint, which divides it into two places. The bisector describes the line. The midpoint describes the location. Basically speaking, they tell us that this whole thing is 10. We know that each of these have to be 5 if this dot is the midpoint. If they tell us this is 10x, we know each of these have to be 5x, because 10x divided by 2 gives us, 5x. Same thing for bisector. Each of these pieces are congruent, and then you can do the math appropriately from there. Now, you have the ugliest possible problem on the face of the earth, and it makes no sense, and I really shouldn't give it to you the next unit, but I'm giving it to you now because you will probably see things that you don't understand in this question, but you'll definitely see two things which you know are wrong. And these are the two things, that anything that deals with complementary will really have no place in proofs. Complementary angles form a right angle and are 90 degrees. The only time you're going to see complementary is if you see something with perpendicular. If you don't see anything with perpendicular, then you know the complementary is just there to confuse you. So for example, if I have two lines, okay, I'm going to make it so they really don't look like 90 degrees. Because it's very obvious that this pink angle here and this dark blue angle here don't add up. Hey, Hafsa, do not look like they add up to 90 degrees. So the main thing to think about is when you are doing it, you will have one very ugly problem. Definitely two of the lines, you will have no idea what it's talking about. But two of the other ones you know are fundamentally wrong because linear pairs form 180. You can only have complementary if you have 90 degrees, right angles, or perpendicular. So if you don't have that, you know that those choices are incorrect. Next, rigid motions. These you should know from Unit 1. We're going to continue to look at them all the time. Basically, our rigid motions can be divided into two areas. And really, rigid motions only can go in one. Rigid motions are isometries. Isometries preserve distance and angle. The ones that don't preserve similarity. And this is dilations. The three isometries that we know about are translation, rotation, and reflection. Because they preserve distance, they also create things that are congruent. Dilations only do similarity. And you will be able, I think I'm missing an I in similarity. Similarity, whatever. The only thing that you'll be able to notice for dilation is if it says something like AB equals 2 CD, or AB equals 4 RS, or AB equals 1/4 TU, because these have numbers in them. They are not congruent because we're going to have to do stuff with the sizes. They might be similar, but they're definitely not congruent. So if you see something on your test tomorrow, because I've only truly taught you congruence, I've referenced similarities to foreshadow what's coming, but I've truly only taught you congruence. If you see things on your test tomorrow that either mention dilation or mention something with these numbers, you know that it's not congruence. Now, because I love to trick you, one of your questions, it says, which ones are wrong? So if dilation is part of one of those, that actually might be the correct answer, even though it says dilation, because I'm asking you to find the wrong choices. I just love to confuse you, because if I keep giving you hard questions, that's how you're going to do awesome on your tests. And remember, this test grade, your challenging test grade, will replace your easy grade. It can also replace your quiz grade. And same thing for your easy test grade. If your easy test grade is higher than your quiz grade that you took on the CFA, your easy test grade will replace your CFA. And then when you take your midterm, if your midterm is higher than any of your test or quizzes, that will also replace it. So that's why it's really important that we stay focused on what we are doing. Okay? Angles and parallel sides. I've already kind of talked about this, but I want to talk about it one more time because it's on 2 questions of your test. You are going tomorrow to get shapes that look like slanted tic-tac-toe boards. You have to pay attention to what angles they're talking about. This looks awful. Let's try again with a smaller pen. So they'll look like tic-tac-toe boards. They'll be drawn a lot prettier than mine. And then they're going to get angles. Be like, here's an angle here, and here's an angle here. And then they'll say, and then maybe they'll give you 2 angles here and 2 lines here. Or they might give you like this one and this one. So you have to determine, are the lines parallel based on the angles and on the lines? Now, again, you only can have parallel if it's corresponding, alternate interior, alternate exterior, or same side. That's the only way you can have parallel. That is it. Now, for vertical, you can get congruence, but you cannot get parallel. No parallel. So in this example where they show us vertical angles, we do not have parallel lines, because all we know is about this 2 lines here and these 2 lines here. That's it. But on this side, where this and this are corresponding, we can have parallel lines, because this corresponding angle matches to this line here, and it matches to this line here. So because they share parallel lines and they share the same transversal, that's how we know these lines are parallel. Here, They don't share the same transversal. And it's not like they're going opposite and these are the same. It's like this is its own idea up here. This one is its own idea down here. So when you see vertical angles, you cannot not produce parallel sides. Angle addition, linear pair, just as a reminder, linear pairs always add up to 180 degrees. So if you have 5x here, and over here you have, let's make it 15x, 5x plus 10. That'll work. All you need to do, because it's a linear pair, is add them up. 15x plus 5x plus 10 is 180. 20x is not going to work. Let's make this 40, which makes this 40. And then I'm going to subtract 40 from both sides. Well, I guess I'm not guessing. Do 40. Subtract 40 from both sides. Divide both sides by 20. X equals 7. Now, here's the key. Just because we know x equals 7, we don't know the angle. So you have to pay attention to what it wants. Did it want x or did it want the angles? So let's pretend it wanted the angles. You don't have to do anything fancy. Just do it like this. Put it in the calculator. Move on with your life. 105. Here we've got 5 times 7, which is 35, plus 40 is 75. When we add 105 and 75, we get 180. So linear pairs, make sure you add the pieces together. Generic proofs, no specific angle measures. So we've only touched on proofs. One of your problems looks absolutely awful. It's like the worst problem on the face of the earth. It's very confusing. It's very long. If I printed it on paper, it would take up almost a whole page. Do not flip out. Proofs, especially the generic proofs, can only be done if there's no angle measure. Okay, now if we're looking at a specific problem, then that's different, okay? But if we are dealing with a generic proof, as long as there is no angle measures, we're fine. So for example, a parallelogram, you don't know this yet, but you'll learn that a parallelogram can be broken up into other things. A parallelogram can be broken into a rhombus or a rectangle. And it can also be broken into a square. So tomorrow you'll see one proof about a parallelogram. It's going to ask you, can you do the same proof for like a square or a rectangle or rhombus? Yes, you can, because all these shapes, that's really messy, are all parallelograms. And as long as your proof does not have exact angle measures, like it doesn't say like 37 degrees, then it still works, even though the shape changes. Parallel lines, two transversals, we've talked about already. Let me just do one more example here. I talked about it on the X, straight line, and triangle one, but you'll have something that looks like this. The main thing is just pay attention to what you see. I think this picture has to do with labeling what types of angles they are. So just pay attention, okay? If you have one, it's only going to work with all the other angles that touch that orange line, that touch the same transversal. At this point in time, you could not say something on angle 1 and something down here because they're not sharing the same transversal. Same thing, you could not have something with angle 1 and something here because they're not touching the same transversal and these lines aren't parallel. So really take your time on that because I'm making you jump all over when you do it. But if you take your time and like, I'll try to bring patty paper, but if you take your time and look, what parallel lines are they talking about? What transversals are they talking about? You'll be set. Last thing I want to talk about real quick is just labeling angles. Okay, The most important thing about labeling angles is to make sure that the vertex is the middle letter. The vertex is the point. So if I have this angle right here, this can either be C, A, B, oh, like cab. It could be taxi cab. Or it could be B, A, and then C. Here, I could do A, B, C. Or I could do C, B, A. They mean the exact same thing. Lastly, I could do A, C, B. Or I could do angle B, C, A. The most important thing when we label is to make sure that our middle letter matches the angle or the point that we're talking about. And as long as we do that, we are good to go. Okay, so this video was quick. It was just a half hour. All I did is I just went over the concepts that are going to be covered on your challenging test tomorrow. I don't know that I might have to do a review for your easy test. I feel the review that we did in class today, the green packet, and the time that you spent yesterday should be sufficient. But because your test tomorrow is so verbiage and wordy, I did want to cover it. So I'm going to say thank you all so much for participating and joining. I thank you for the people who signed on that I see that texted. So Kaiwan, Hafsa, Shamit, and Ashley. And anyone else who's not here, thank you for joining us. If you played football, I hope you had a good practice and you're watching it now. And I will see y'all tomorrow. We will be in the computer labs. I believe it's A109, but I'll leave a sign on my door. All right, y'all. Bye. Stop being shy. Yes. Oh, Izzy too. Bye, Izzy. You surprised me.